My name is Adam Buckner, and this is live training from Unity Technologies. Today's session is going to be coding for the absolute beginner, and today's session is not going to be very sexy. We're not going to have a lot of, gorgeous looking art to look at tonight, and it is a very, very basic class which is meant for people who have absolutely no coding experience. I want to do a quick recap on how Unity does it, as it were, what Unity does using game objects and their attached components. Remember that we have our empty game objects. We've got our game objects. All empty game objects, they come with a header and a transform, which is its location in 3D space, which we can see here with one of the transform gizmos, with the translate gizmo. I'm going to reset that to center and then frame selected on it. And our game objects, the behaviors of our game objects, how they act and how they behave, are determined by the different components that we put on our game objects. And if we look at this camera, we've selected the camera now, we can see it has a camera component, and it has a GUI layer, a flare layer, and an audio listener. These are all components, and they all do things. They all change the behaviors of our game objects. If we wanted to create a 3D plane, we could just simply come to the Create menu in the hierarchy and create a plane that will go into our game. And we can see that it is different components. It has the mesh filter holding the plane mesh, a mesh collider, a mesh renderer. If we're going to make a sphere, 3D object sphere, I'm going to lift that up so we can see it. It also has a mesh filter with a different mesh in it, and a sphere collider and a mesh renderer. And so it's these components that are telling our empty game objects what to do. And if we want to make a light, we could create a light, create a point light, bink, and we have a light. On the other hand, we can also add these components manually. Let's take that empty game object. Let's call this our light. And we can add a component, and that component, let's add I believe it's rendering light, and we can make a point light. And so we've made that same object that was pre-built in Unity. Unity basically makes these pre-built objects, but they're the same things. They're simply components being added to the game object. Now, pre-built game objects and pre-made components don't make a game and gameplay. We could do things like give our sphere a rigid body, so it now has physics, so not 2D, 3D please. So it now has physics. And then I'm going to go and enter play mode, and when we enter play mode, the ball falls down and lands on the plane. And these are pre-described components again, so that rigid body allows us to allows that ball to interact under physics, and drop it again. And so we now have physics behavior. But this doesn't make a game, this is more of a simulation. To make a game, we as game developers need to be able to write specific behaviors of our own. And we do that by writing scripts. What is scripting? Well, scripting tells our game objects how to behave, and it's all of these scripts and all of these components on all of these game objects and how they interact with each other that creates our game and our gameplay. Now, scripting in Unity is different from pure programming. If someone else has touched some pure programming where you're creating a little running application, we should realize that we don't need to run anything with the scripts that we write. Unity is running. Now, Unity runs in a big loop. What we're seeing, even now in the editor, is Unity running inside of a big loop. What it does is it reads all of the data that's in the current scene. It reads where the meshes are, it reads where the lights are, reads what the behaviors are. It processes all of this information until it has all of the game objects in a particular position, and then it renders a frame. And if you think about film or television, where you've got motion picture film at 24 frames a second, or you have European television running at 25 frames a second, or you have North American television running at 29.9753 frames a second, which is a whole nother story. Unity needs to do the same thing. It's running single discrete frames, and it's just putting them up one after another, so we get that sense of motion. And so what we do with our scripts is we push Unity around with our code. We direct Unity with the instructions that we write in our scripts. Now, a script must be attached to a game object in the scene to be called by Unity. There is possible to you can write various bits of code that are not attached to game objects in the scene, but they must be called from some script that is instantiated in the scene that's attached to a game object. Now, how scripting works. Scripting uses logic, not maths. Many people think that this is all has to do about maths, and it's not to do with maths at all. It's about logic. To drive code that is pre-built into Unity. That code that's pre-built into Unity is the Unity game engine, and it's accessed through something that's called the API, or the Application Programming Interface. And we don't have to really worry about the name, but we can find the API in the scripting reference, which I'll talk about a little bit later. And scripts are written in a special language that Unity can understand. And it's through this language that we will talk with Unity and give Unity our instructions. Now, the languages that we will be using C# today. And C# is a common scripting language. It's possible to use other languages with Unity, but this is not going to be covered today. All of the languages that Unity works with are called object-oriented scripting languages. And one of the most common is C#, which is what we're going to be using. Like any language, scripting languages have a syntax. They have parts of speech, as it were. And the primary parts of speech that we're going to deal with are something called variables, functions, and classes. There are other parts of speech, but we were not going to get into those today. So let's go ahead and start a new script. So what I'm going to do is I'm going to create a C# script. And we can do that with create, and it will create a C# script here in our project view. So this is an asset. It's a text file. It's being saved in our hard drive. And then let's just go ahead and call this something like example script or demo script. Let's call it demo script, because we're demoing things today. So that's our demo script. And if I look at this in the Finder, we can see that this is just simply a text file. And I could open this up in TextEdit. On Windows, I could open it up in Notepad. But what we have bundled with Unity is a very sort of powerful text editor called MonoDevelop. And it's some people call it a developer's environment. And it gives us a lot of very useful functions. It can help us complete our code. It can tell us when it thinks that we're writing code that is wrong. It allows us some shortcuts that will take us directly to the API, or to that application programming interface. Now, you can use other text editors. You can use Notepad. You could use TextEdit. You can use Visual Studio. You can use Sublime Text. So here we have a script, a sample script with some sample code in it. And so we have variables, and we're going to have functions. I'm going to make that bigger in just a second. I haven't done that for you. Functions and classes. And then let me just quickly make this bigger. There we go. So we have variables, functions, and classes. And what do these things do? Well, variables, they hold values and objects. They're like a box that holds something for us to use. And then we have functions. And functions are collections of code that compare and manipulate these variables. And finally, we have classes, and classes wrap collections of variables and functions together for use and reuse later on if we need them. And scripting is primarily comparing these things or objects and their current states and values, and based on logic, not math, determining an outcome or resolution. Now, I'm going to write a very simple script, and I'm not going to explain a ton of what we're doing right now. And then I'll go back and I'll explain some of these details in a moment. What I want to do is I'm going to get rid of all my code, and I'm going to create a public variable. And I'll explain this in a second. Public variable called, of the type light, and I'll explain this in a second, called myLight. And I want to do something with this light in a function called update. And update is called by Unity once every frame. So when Unity is going through its loop, and it reads all of the instructions that we've written it on all the scripts, on all of the components. And before it renders the frame, it'll look for every script with an update function, and this is an update function, and it'll run all of the code that is inside that update function once every frame. And then when it's done with all of the scripts and all the components, it renders the frame. Goes back to the loop and does it again. And so we're going to say, every frame, I want you to check this piece of logic. I want to say, if the input from my player is the key, and I do this with getKey, space, the space bar, is getKey space. Then I want, if that's true, if it's the space bar, I want my light, come back here, my light, I want its enabled state to be set to true, which is the equivalent of being turned on. I want it to be on. I want to turn on the light. So if it's the space bar, I want my light to be turned on, or else, if it's not being held down, I want my lights, its enabled state. You can see it's offering, the IDE is offering me a suggestion. Its enabled state will be false. And just as an aside, we will see that all of our logic is inside these braces, or also known as curly brackets. And so we can see there's our if statement. And then we say everything that goes on between two brackets is what happens if that's true. And so you can see there's the two if statements. There's my light.enabled true, or else my light.enabled is false. So let's save this, and we come back to Unity. And Unity, there's a thing called compiling, which is basically taking all of our scripts and mashing it all together into a working bit of code. And Unity does that for us, so we don't have to worry about it. So essentially, as long as we have saved our script, and Unity looks at that script in our asset folder on the hard drive and notices that the date that it was modified has changed. So it will re-import that script, and those changes will be recompiled. So this script now needs to be attached. So well, actually, it needs to be attached to any game object. Because we have a public variable, it doesn't necessarily need to be attached to the light, but we'll do that for now. And then I need to make a reference to this light. What light do I want? I can pick any light in my game. Let's go ahead and just fill that in. So I've grabbed the light I want to change by putting that into the public variable. And then let's save our scene. Let's just call this demo scene. So now if I save the game and I play, we can see that my light is turned off. My light is turned off because I'm not holding down the spacebar. I hold down the spacebar, my light's turned on. Lift off the spacebar, my light is turned off. So essentially I've made a switch that turns on my light by holding down the spacebar. So every time I hold down the spacebar, I can turn on this light. And that is with this logic where I'm saying every frame check to see if I'm holding down the spacebar. And if I am holding down the spacebar, then take the enabled state of my light and make it true, or else take the enabled state of my light and make it false. And what we're doing in the component is, if we look at the light, that's this little button here. So there, and let's get out of play mode, because every time I click it, it's going to turn off. So essentially what I'm doing is this is the enabled button. So therefore it's the enabled state. So that logic is looking for the light by its reference and turning it on and off, turning on and off this particular checkbox. Now, there's a bunch of different, they say a bunch of logical ways that you can solve any issue, a bunch of different ways you can skin that digital cat. And so let's make a quick change to our script, because I just want to talk about show how this is logic, and I'll get into some more details in a second. So if I say if input get key down, so now I'm not saying is the spacebar being held down, but is this the frame that the key comes down? This is only a single event. This is the act of pushing the button down. Not whether it's held down, but whether this is the frame that the key is depressed. So when the key comes down, we want to set my light.enabled to be true. And I'm not going to have the else anymore. I'm going to say, as a whole nother line of logic, if input get key up is the spacebar, then I want my light enabled to be false. And this again is another single event. This is the act of the spacebar coming up. This is the frame that the spacebar is released. And so this is going to essentially look very similar to what we did before. So let's come back here. Let's hit save. and let's hit play. The big difference is our light stayed on this time. And that's because I haven't touched any key. Now, I hold the button down, and my state now goes from on to on. If the input is the get key down, turn on the light. Now I lift it up and it turns off. So the behavior is almost identical. I can make the behavior identical by selecting something in the editor. So sometimes there are times when we're writing our scripts and we need to do it all in code, and sometimes where we can also pre-work something in the editor. So if I want the exact same behavior that I had with that first script, I need to turn my light off. So it starts in the off position, because in the first logic, if I'm not holding down that button, the light is turned off automatically on the first frame. With this one, it's simply looking for the key down and the key up. So let's hit play, and now the behavior is the same, which is that the light doesn't turn on until I hold down the space bar. Let's quickly look at a third example and say, again, we're checking every frame in our update. If the input is the get key down space, I want to say that my light, its enabled state, is equal to an exclamation point. And what I want to show here is that there are these uses of characters. I mean, we all know what the equal sign is. What is this dot sign? I'll get to that in a second. And what is this the exclamation point? The exclamation point actually means not. So I can say, I want my light enabled to be equal to not my light enabled. So what I'm asking is to Unity, can you please, if the input gets the get key down, I want you to set my light's enabled state to the opposite of its current state, to what it is not. If we think about this enabled state, it can only be on or off. So it only has two states. It's what's called a Boolean. So in this case, I have my light.enabled equals not my light.enabled. So when I'm in play mode, every time I touch the key, it simply swaps the light. So what I've made is a toggle button. And so what I want to show here is the subtlety that you can get when writing a script, and that there's a bunch of different ways that you can write a script, and none of them are particularly wrong, and that some small changes in code can either make a very small change in your script or can make a very big one. Now, the API, or the built-in functions, are very important because this is how we drive the Unity game engine. Now, the easiest way to get to the API is through the scripting reference, and the easiest way to get to the scripting reference is to go to the help menu and say help scripting reference, and it will open in another window. There we go. There's our scripting reference. And so this is the scripting reference. You can pick the language you want, which is Unity's version of JavaScript, which is not to be confused with the JavaScript that people write web pages in. It's a different language. C# and Boo. Boo is a Python-like language. And this is, you can read it. It's a lot like reading a dictionary. It's also very good for looking things up. If you want to know how to script to a rigid body, you can say, I need to script some physics. How do I script to the rigid body? You type it in, you search, and there is everything we need to know about the rigid body for scripting. So we can look at that scripting page and we can say, here's the description. You know, adding a rigid body to an object puts its motion under the control of the physics engine. And then we have all of the variables that are built into the class and the public function, so we can start to see how to use it. And we can also switch with this button to the manual, which gives us the description of how to use the component inside the editor. So the manual and the scripting reference are very important, a bit dry, but definitely worth knowing where it is, even if you don't read through it. One little trick is when we are in MonoDevelop, and this is true for a lot of the third-party IDEs as well, for scripting editors. If there's something that we want to know about, we can select it, and we can hold down the Command key on the Mac or the Control key on Windows and hit the single quote key, and this will open up the scripting reference and with the search term that we have highlighted in our script. So I wanted to know about input, and now I have an entire page on input. Don't even have to go and look it up on the web. I can just say Command or Control, single quote, while I've selected some term or some keyword inside my script. Now, let's talk about the anatomy of a script. So I can see in the chat channel that I'm being asked about touch input. Touch input's a little bit more advanced, but if you want to find out about touch input, how about you do this? I want to find out about touch input, and I'm going to put it behind 2 slashes. 2 slashes means that this is a comment, and so the compiler, the thing that is building our scripts into the game, will ignore any of the stuff behind it. Let's say I want touch. Let's say I can spell touch correctly. Highlight it, Command or Control, single quote, and here is all of the information that you need to know about touch. So if you want to update something for touch, go into your script that has input for keyboard and mouse, type in touch, and you'll get the documentation for that particular thing. So now, looking at the anatomy of a script, our scripts start out by laying out the tools that we need at the top. And this is usually declaring variables. And we can see that we've declared our variable here with the keyword public at the front, and then a type, and then a name. When we are declaring our variables, there's 2 types. There's public and there's private. Like my other light. And if I save this and come back to Unity, we'll see that we can access and we can see the public light, but we can't see the private light. And that's because anything that is defined as private can only be accessed within this particular script, within this particular class. If I was to make this public, it's now accessible to other scripts and other classes inside Unity. So it's basically, we're making it public. It means other people can access it. Other people can change the data. Other people can change the reference. So a little bit beyond what we're teaching tonight, but be aware that you can make things public and you can make things private. When the next thing that our variable needs is a type. And why do we have a type? And the reason that we have a type is that Unity is doing things to our variables. And it needs to know what type of variable it is. And if you think about it, what a type is what is that defines our component. Our transform, that's a type. Our light is a type. Our demo script is a type. Our mesh filter, our mesh collider, our mesh renderer, they're all types. So just as an example, you can see that we'll get some code completion here. I can have a color. I can have a camera. I can have a rigid body, and all of these things are types. We can also have an int, which is a number without a decimal place. We can have a float, which is a floating point decimal number. Int would be like 1, 2, 3, and float would be 1.1, 2.2, 3.3. We could have a string, which is a string of characters. So that's, you know, my string is a string of characters, so it's text. We can have a bool, which stands for Boolean, which is the true-false, the on-off that we were using, that light.enabled. And the reason we need to know our type is, just think about this. If you're going to be trying to add 2 things together, and the types are int, and Unity, when you're at compiling, looks down and says, hey, I've got 2 ints. I can add, you know, I want to add variable A plus variable B, A plus B. And A is an int and B is an int. Yeah, I can do that. And in some cases, you're trying to add A and B, and A is a float and B is an int. Yeah, Unity can do that. Then you write a piece of code, and A is an int and B is a camera, or B is a color, or B is a rigid body. You can't add them together. So Unity will throw an error and say, sorry, these 2 things don't work well together. Try again and come back to me when you have it right. So that's why we need to know our type. Is Unity wants to know what type of thing this is, what type of object this is, and needs to know how to manipulate it and how to handle it. So we need to give it not only whether we are keeping it public or private, we need to tell it what it is, and then finally the name, which is any name that we choose. The main thing that you can't do is you can't start it with a number. What we've chosen to do, and this is very much throughout the way that Unity works and a number of other applications and people who are doing coding work, is that we have a style of writing our our names. And with variables, we always start our variable names with a lowercase letter. In this case, you can see that mylight is starting with a lowercase m, and we'll see that functions start with an uppercase letter. Unity is nice, and when it sees that information, we'll make it more readable. So there's mylight here. It's capitalized the M, and so you've seen the capital there of the L, and it's given us an extra space. So that we get mylight. It's called Pascal case, if I remember correctly. Those public variables we can access inside the editor, in the inspector. But once we've created our variables, then scripts need to manipulate these variables. And so scripts manipulate these variables by using functions. Functions do things to variables. There are a number of functions that run automatically inside Unity. There's awake. Let me write this properly. There's awake. You'll also find start. Not start coroutine, please. Just start. And then there will be update. And sorry, I've got, let me just quickly put this behind comments. The other way that you can do comments is with /star. And then you can end it with // And anything between /* and // will be ignored by the compiler. Then there's fixed update. These are the most common ones that you'll find, and then there is late update. And why do we have these? Because they all do different things, and they're called at different times. Awake is the function that is called, pretty much called first. This function is always called before the start function, and it's called when the game is, usually it's called on the very first frame of the game, when that game object with its component is first instantiated. If you create something at runtime, then awake will be called. If a game object is inactive, then awake will not be called until you wake it up. And then start is called if a game object is inactive. Of course, during the start period, awake won't be called, and neither will start. Then update is called once per frame. So we read all of our code, and then update is called. And this is where you put code to do things. Then there's fixed update, and that's a real special one. Fixed update is called when you want to do physics work. So why do we have update and fixed update? Well, let's think about it in the case of a space game. Let's say you have a space game, and your render speed is going to depend upon how much stuff is going on. So if you have one spaceship and you've got your star sphere, and you may have some particle systems for your engines, not a lot going on, you're going to have a very high frame rate. You're going to have much higher frame rate than you need for your game. And you don't need to waste that time doing complicated physics calculations. So you can hold off on doing your physics. And so the fixed update is done at a regular pace. Now let's think about this at the other extreme. You get into that space battle in the middle of the asteroid field, and there's lots of asteroids, and there's lots of enemy ships, and there's lots of particle systems of explosions going on. And every one of these things is moving and tumbling and changing, and there's a lot of processing that's necessary, and your frame rate's going to drop. You don't want your physics now to start malfunctioning because there's so much going on that your frame rate's lower. You don't want ships to pass through each other. You don't want missiles to miss hitting an object. So again, you want to have a very regular fixed update. So the way fixed update works is it's called by the physics engine, and it's called at a regular time, not based on the speed of rendering, not based on how fast the game loop is going, but it's based on a specific time tick every 10th of a second or every 20th of a second, and then it will process the physics so that you have a regular physics update. Now, late update is simply another function that is similar to what update is called. And when you have a late update, it's called at the end of the frame. So Unity will look through all of the game objects and find all of the updates. And once it's called all of them, it'll then call the late updates. And this is good for things like cameras. Because we don't have a very tight control over the exact order in the frame of which objects are going to be called and which objects are going to be called first. Let's say that we have our character and we move our character, and then he's bumped into by another character and ends up in a different position. If we moved our camera at the same time as we moved our character, we could say the character could move, the camera could move, then the guy could get bumped, and there would be a jiggle, and the camera wouldn't be where it needs to be. So if you move your character and the enemies during your update phase, and then in late update, after all of the updates have gone, you can then move your camera, and you know that it will always be perfectly lined up behind your character. So essentially it's a second loop that's optional that you can use, and there's sometimes that it's a very useful second loop to have. And again, if you want to know more about that, that's looking at the execution order, which describes the order at which case all of these internal functions are called. Now, writing a function. Let's talk about writing a function, because Unity calls a number of functions that are very useful for us, as we can see here in Update, but also there are our own functions that we want to call. When we write a function, functions start with the return type of the function at the beginning, followed by the name of the function and the parentheses. So we can see that here with void, that returns void, and I'll talk about what exactly a return is in just a second. Essentially, nothing is coming out of this function. Its name is update. There are parentheses, and then there are brackets that surround the block of code with the block of logic that we'll write. Functions, their names start with a capital letter. And then inside these braces or curly brackets is where the content goes. So we could write a function by saying void my function. And you can see capital M, and then parentheses, and then curly brackets. And inside that goes some content. Now, how do we call this function? Because Unity calls update for us. That's nice. Calls late update, calls await, calls start. But who calls my function? Well, we have to find a way to call my function, and we either call it from another script or we have to call it from inside one of the scripts that are running from one of the functions that Unity calls. So it needs to be called from awake, needs to be called in update, or can be called from another script. Say when someone clicks a button, when that button click comes down, they can call that function. So let's take this as an example. Let's grab myLight.enabled equals not myLight.enabled. I'm going to cut that out. I'm going to paste it into my function. Now, it works perfectly fine in update, but let's go ahead and put it here under my function. And in update, I can call my function simply by the name and the parentheses. So I'm calling my function with the name of the function and the parentheses. So let's come back to Unity, and we'll see that the behavior is exactly the same when we go into play mode. Except that now inside the script, what we're doing is in update, we're looking for the key press, and then when the key press happens, so if in our update we get our get key down space, we call my function. So now we're calling my function, and then my function is doing that code. So now we'll still see no apparent difference, but I hope you get the point. So there's no difference in the way that that's functioning in the scene, but there's a slightly different in the way that that's functioning inside the logic. So let's talk about returns from a function. Functions can do calculations and then return a value. So you can ask a function to do something and process some information and then give you back an answer. But that means that that function needs to return it to you. And again, like having the type for our variable, Unity needs to know what type it is to know what to do with it. We also have to type the return from a function. And it's not void. Void is when you return nothing. So to do this, you need to send a function something to work on. And this is what the parentheses are for. So let's say we want to add 9 and 2. And we'll do that in awake. So when we start our script, we want to simply add 9 and 2. So what we can do is we can make, and this is wrong, let's just put in void because we're used to seeing this. Void add 2. Like I said, be careful that is wrong. So there's our function add2. We want to add two numbers with this. And we want to do this when the script starts. So I'll do this from my awake function. So as soon as the script wakes up, it's going to send this code. And so what we'll do is we'll call add2. We'll just call it. Hey, I've called add2. But it doesn't do anything. And how do we send these numbers? Well, as I said, that's what these parentheses are for. So I can send 9 and 2 to add2 inside the parentheses. And add2 now needs to accept these inside the function. And we do these by making parameters. var1 and int var2, because we're adding 9 and 2. So these are essentially little variables. We've got our type. We don't need public or private because it's just used inside the this parameter list. So we have a type and we have a name, and again type and a name. And we are sending them here with 9 and 2. And then just for nomenclature, this is a parameter, and you send arguments, which could be different numbers anytime you do it. And then inside our function, we need to make a variable to hold on to this number. And so again, we need to type it with our int. And let's just call it return value. It's going to equal var1 plus var2. So now we have a function that takes in two variables, adds them together, and sticks them into return value. And literally, we just simply return our return value. But this won't work. If we save this, we're going to get an error. Because, oops, let's go back to the error, which is what I wanted to do. Because the error says a return keyword must not be followed by an expression when the method returns void. So we need to put a type in here. So let's get back to our script. And so we are returning an int. So now that we do that, we return the int. Now this is kind of useless because nothing happens to this value. So we need to grab this value when it comes back into awake, because right now this just goes off into add2 and then sort of disappears like a river into a desert. So let's go ahead and grab that information, that value, when it comes back with another int. We have to type it called, let's just call it myvar for a variable, equals add2. So essentially we're going to, the logic says an int variable called myvar equals the return value from add2, and we're adding two numbers, 9 and 2. They come in as arguments into the parameter list. Then they get added together and put into return value, and then they get returned back up to awake. So let's go ahead and put this in our log, debug.log, myvar. So now we can see this. Save your script, go out of play mode, and then when we start, we'll see that 9 and 2 equals 11. Now, classes. Classes are collections of these variables and functions. This script is a class. Oops, come back here. This whole thing is a class. And what's important to know about this particular class, when we write our scripts, the class name must match the file name of the C# script for it to work. And then to be attached to a script, it has to what's called derive from another class called MonoBehavior. We don't really have to worry about that right now, but just realize that when you're making a class to attach as a component, it needs to have its own script. The script needs to match the file name, and it needs to have this : MonoBehavior, which is automatically put there for you when you write your script. Now classes, they can be instantiated and referenced with a variable. So we can create a class, we can create a data class, so that holds things. So we could make a public class, and yes, classes can be public and private as well, called a data class. And it doesn't derive from anything. And it simply holds, say, an int my int, great, an int, let's make this public int my int, and public float my float. And we can make an instance of that by having another public data class, my class. However, this is a Unity thing. It's not going to show up in our inspector when we look at our light. And this is just something that you need to be aware of when we're dealing with Unity, is that we have to serialize our custom classes. And I can explain that to you later, or you can research it. But essentially, if you create a custom class like this that you want to hold a little bit of data in, you have to ask it to serialize it for it. Call it serializable. And this means that it will be converted into simple data that Unity can look at in the inspector. And when we do that, we will now see that we have our little class in here with our float and our int. So this is a very quick introduction to scripting and being able to do things with scripting in Unity. And I'm going to probably do a couple more of these as we move forward. I would like to get into Q&A based on this, based on scripting. We've talked a lot about other things, but today's a class on scripting, so I don't really want to talk about anything else other than introduction to scripting and the very basics of scripting. So if you have questions, if you're a new user and you've seen this and you either understand it and you have an epiphany, or you don't understand it at all, start posting in the chat, and I'll try to get to as many people as you can. So this is a very basic introduction to scripting. I want you to see what variables are. I want you to see what functions are and how they are constructed and how you do things with them. Pustlataga, 50 minutes seems like 5. Well, thank you. I mean, in one sense, it means we got a lot of data across, and it wasn't, you didn't feel bored. The question from Sparrow BG, why don't we use this for an object we are attaching the scripts to? I mean, the this keyword you can use, but you don't need it in this case because you're just attaching things. If I'm understanding what you're saying, you're attaching things directly. Though this is going to change a little bit going into 5, you could do things like this where you say private rigid body, capital R, please, rigid body, my rigid body, and then in awake you could define this by saying my rigid body equals this dot rigid body, and rigid body with a short r, with a lowercase r, in 4 is a helper function that will find the rigid body component. Going into 5, this is going to change. But on the other hand, you could also, it's not necessary. If some people like to do it, my other rigid body, you could simply do this. And then remember, this is in 4 and will not be in 5. And I'll show you what to do in 5. My other rigid body equals rigid body. So this works in this context, but isn't necessary. So it depends how you like to write stuff. And I can't think offhand of a specific time you must use this, but it's available. In the future, going into 5, you would need to do a get component. And this is so we can modularize the base engine and get rid of some interconnections, some dependencies inside the base, inside the core engine. So now you would need to initialize these and set your references by saying my rigid body equals get component rigid body. And this is a generic. And my other rigid body I would make public because it would be on something else. Or I could find a game object and then get the component on the game object. Actually, you could do that. You could do something like my other rigid body equals game object dot find. How about find with tag? Because I know this will work. And I won't be leading you astray. Find with tag player. Close that. Dot get component rigid body. And so I'm finding the first game object that's tagged with a tag player, and then grabbing the rigid body from it there. And daughter, my phone rang when you were explaining class types. I think I didn't quite get the part that isn't void. Could you please repeat what you did with that class? Well, first of all, it's archived, so you can look it up, but you don't want to wait the 2 days it'll take me to get it up. We're talking about return types from a function, not typing a class particularly, but return types from a function. If you return a value, in which case we were returning a value here, we need to specify the type. And it's a bit pedantic because we know it's an int because we declare it here, and we return it. So why do we have to declare it here? Well, that's just part of the language. And then it comes into an int. So as long as all of those match, you won't get an error. So we're adding two ints together, saving it in return value, and we're returning it. But if we had this as void, we would get an error. If we also had this as something else like a float, I think we're going to get an error as well. Yeah, because it cannot implicitly convert the type float to int, and an explicit conversion exists. So we could make this work without trying to force this return value to being something else. So we just need to return it. But if we did something that returned a string value, we'd need to do that. We could change this logic, adding to int return value, and then do something along the lines of if return value is greater than 5. New, let's make this a string new return val. Let's make it value all the way. If return value is, let's make this equal to nothing. So we have an empty string. But if our return value, which is our adding the two things together, is greater than 5, this is a long explanation for something that is relatively simple. New return value equals hello. For whatever reason. Now we would have to turn this into, because we're returning a string. Oh, then we have to return that. Return new return value. We'd have to make sure that we type this as our string. Yex Lord asks, why would I need two classes in the same script? You don't. But sometimes for organization purposes, if you're using a class, especially for a data class, one of the things that data classes can also be used for convenience is that if you're making a list or an array, you're making a collection, and you want a bunch of things like an inventory item or something, so that you can have... Oops, what have I done? I may not have fixed something. Oh, int, yes. So this is, we just, yeah, that doesn't work anymore as we've returned our string. So let's just go ahead and, let's just strike this out for now. So now we have a collection of these data classes, more than I wanted, just 5, please, for doing things that we want in our script, for whatever reason. And to keep things associated, why not define the class in the script that uses it? Because if this is only used in this particular script, why not? Because otherwise you're going to have a little script that's this long to define this class. So as long as that only one of the classes in the script derives from monobehavior, so it can be attached, you can create as many data classes or additional classes that you need in the same script. And you'd only want to do that for organizational purposes, so that you sort of knew that your data class here is just defined very quickly at the top of the script. And Vesga, where can I find a full list of the functions that are available? In the API, we'll have lists of all of the functions that are available, and the ones that are called by the game engine, you can find on that that page that I posted before, the execution order of event functions. And these are simply the event functions used during the game loop. On application pause, fixed update, update, late update, and then a bunch of rendering and coroutine stuff. So you can find the ones that Unity call here, and then all of the other ones you can just simply get from looking at the scripting API, because there are functions that you can call from many, many classes that are in the API that you can find in the scripting reference. Farple Duper asks, can you talk about the difference between public and private? Briefly, yes. Essentially, there's a thing called scope, where you want to maintain certain parts of your code inside certain scopes. An example would be that when we're dealing with our add2 down here, we created an int variable here and a string variable here. We created them inside this function, so the scope is inside this function, and nobody else in the entire game can find, touch, see, feel, change that value. It's inside the scope of this function. Now, these variables are inside this class, but we can choose whether or not we want to expose these to essentially the outside world. If this is something that we don't want anyone to change, we don't want anyone to accidentally bump, and by saying anyone, we mean ourselves or the other scripts that we write. If we have a health value, sometimes we don't want to accidentally change that health value of our player, or how well his armor is doing. So we create a function that can add or subtract from it, but that value stays private inside the class. And often it also keeps from being a clutter, is that we could have these public in our script, and then when we come back to Unity, we just end up with lots more stuff in our inspector. And if we aren't intending to drag the reference from one place to another and make a drag reference into that public field, and we don't need to change or reset that value from another script, then you might as well just leave these as private. And just as you're aware, the way C# works is that if you don't use public or private, it will be private by default. So these, by removing that keyword, so we don't have public or private in front of it, they will disappear because they will be private. Raj24 asks, does C# use protected as well? Yes, when you get into inheritance, you'll need protected and virtual and all of those keywords. Tony Kusha says, does public mean the variable can be accessed from another script? Yes, it can be. Katheo answers the question of Mental Twitch TV and says, you would want to use awake over start when setting the values to variables in the class that is referenced from other files when being created. That makes sure your variables are set before you've called your start and update. Yes, there are times that you want to use awake over start, and often I use awake to initialize a lot of the values within a script so that they are ready for other scripts that are talking to them when they arrive. And I probably could have given you a little bit more explanation when I was giving that information. But one of the examples that I like to use is I like to use awake as an example of waking up. And you go, you wake up and you brush your teeth and you get ready for the day. And you get your clothes ready so that when you start your day, you are ready. So if someone knocks on your door or calls you on the phone, you are ready to receive their phone call. That's sort of my way of awake and start. Nuake Ball asks, can you make scripts that are classes in and of themselves? Yes, you can. We could create something, just create a script called utility script. And then we could make a, get rid of all of this stuff and just make a public class, another data class, assuming that we're not making another one that we want to attach, but just another utility script, and then we'd have a public my string. Oops, we need the type string, my string, and a public color, my color, and public. I don't know what we want. Game object, my game object. We can save this, and we can then make, and system serializable, because we want to see that and we want to be able to do things with it. So let's make that serializable. And then when we come back to demo script, we can now have public. Okay. Did I call it other or my other? No, I have to look back at what I called it. Another data class. Another data class. Let's make that a list as well. My other class. And so I'm making instances of it here in demo script, and I've defined it here in utility script, and you could have multiple classes and things that you defined here, or enums that you wanted to. And then when we come back to Unity, we can see that we now have my other class. But what's interesting about this is I made a string. We've talked about this in one of the tips and tricks ones, but because string is my first element in this list from another class, I can actually, the element will take on its name. So you can see that this now says Ulysses. We can now have Beagle, something like that. So we can see that we've now made another utility class that's defined in a script all of its own. And we're made an instance of it in demo script, and we're populating it as public here in the inspector. Mr. Mariosa, sorry, I've mutilated your name. Can you please recommend an intermediate book for C# and Unity? There aren't any. But I can't find any good books that I would recommend, and I have bought several and been disappointed with all. One of the places that I would recommend people to get more C# knowledge is a website called C# Station, and you will learn the language. My frustration about it is that it's not related to games or Unity. Why is that not coming up? I'd be very sad if they've gone C#. Ah, that's because I spelled it wrong. Yeah. So you can at least learn the language here. And again, they do go through some of the stuff that we've done today, what types and variables are, and what methods and functions are, and namespaces. So it's a well worth doing, except you will be making little tiny applications and you'll be running them. So it's a little bit different than what you need to do when you're dealing with C# for Unity, but it'll at least give you the basis of the language. Can you explain what a prefab is? Yeah, I'll do that briefly. It's a little bit not what I wanted to talk about today, but if I'm waiting for people to put some stuff, I'll do very quickly. But essentially, a prefab is a prefabricated fabricated group of game objects that you can save as an asset. An example would be, let's create the sphere that we have. Let's go ahead and add a light to it. So we can add component light to our sphere. Or let's add a particle system. Miscellaneous. Where's particle system? Well, we'll search it for it. Particle system. And oh, I attached that to the light. Let's do that to the sphere. Particle system. So we now have a particle system attached to the sphere. And then I'm going to, just make some settings. And now I can save that by dragging that into our dragging that into the project window. So now it is an asset, and we can see that on our desktop as a prefab object. And now I can drag that into the scene, and wherever I drag it into the scene, they will be perfect replicas for that. Now, this is a bit ugly, but the example would be, let's say you had a treasure chest in your dungeon, and of course it's going to lose the prefab. I'd just like to delete those, please. Thank you. So you have a treasure chest in your dungeon. You make one treasure chest. You put the script on it for the logic for loot, one animation, one trigger, and so you have the perfect working treasure chest. And then you save that as a prefab. And then anytime you need a treasure chest in your dungeon, you can just add it to the dungeon. If you need missiles for your spaceship, then you can instantiate those prefab missiles at runtime. And if you need to make a change, you can make a change to the base asset. So notice I'm going to come in here and I'm going to change the color of the asset, and then I'm going to put that into the scene, and we've changed the color of the object. So if you do something like say, oh dear, I need different music or a different sound when the lid opens on my treasure chest, you can simply change the asset, change the prefab asset, and all of those changes will propagate. Actually, let me just show you that again. So these guys are in the scene, and then now I want to change it again, even though they're in the scene, to another color. And you can see now that these guys are spitting out different colors. So essentially it's saving your game objects that you need duplicates of as an asset. Can I continue this course with more totally for beginners lessons? Yes, I can. What I would suggest is for people who want, who have suggestions and want to remind me, go to the forums, go to the community, go to our forums. Or I suppose I keep getting the community. Let's go to, there we go, forums. And into teaching. And then into free online training. And tell me whether you loved it, you hated it, how you felt about it in general, and also suggestions for new classes. And that's where one of the places, that's one of the places I go to when I'm coming up with the new slate. Usually I try to work 3 to 4 weeks in advance, so I already have 3 or 4 weeks worth of classes already up, but I'll continue this, especially if there's something more you want to see. And tell me what it is specifically that you'd like me to cover. How do I create gravity like Angry Birds Space in Unity? Well, I wish I knew what Angry Birds Space was, but if I remember correctly from seeing a demo on something similar, it is that objects pull towards the center of objects. Well, coming in 5, there will be 2D effectors, and you can simply just add an effector component to your 2D object, and you can make it attract to a point or repel from a point. You can, with 2D effectors in 5, you'll also be able to have one-way edge colliders, so you can jump up on top of there's sort of a Mario style thing where you're running at the base along a platform, but it's solid, and you can jump up and sort of land on top of it. So essentially what you're doing in 2D is going up through a collider one way and then not being able to penetrate it back the other. Otherwise, you need to get into some maths and program it yourself, which is entirely possible. And I have something that I used which is similar. It's a very simple thing, if I can find it. Just because it may be, the math is already, there we go, simplified black hole. So you might want to just read up on this because essentially I made a gravity well for a small game that I've done. And that may help you make something that attracts towards the center point. But I don't know Angry Birds Space well enough to know if that's exactly what you're looking for. Archangel07 asks, in Unity, do we have to worry about complex hardware things like memory management or anything? To a certain degree, it depends how far you want to dig, but on the outset, the answer is no. Memory management is done, including garbage collection, by Unity, so you don't have to worry about specifically deallocating stuff that you've put in. There are some issues if you end up with too many allocations and you create too many objects and destroy too many objects, and then garbage collection is working all the time. It can take some performance away from your game. So there are some techniques, especially pooling, which can help reduce the amount of overhead that you have by putting things into memory and then removing them and then cleaning up the garbage. But essentially that's done by Unity internally, so you don't have to worry about that yourself. Raj24 asks, so does Unity 2D use box 2D for physics? Yes, it does, and for 3D it uses PhysX. Any more quick questions? What tutorial should we look at next? After this particular tutorial, I would suggest and I keeps opening in the other window because that's where I have Twitch open in the other window so I can read you guys, but that's where it wants to do that. So I would go to Learn, and I would go to our tutorials, and I would probably run Rollerball and Space Shooter. I'd probably go Rollerball, Space Shooter, Survival Shooter, Stealth, in that order. And at the same time, referring back to any of the topics that we have here. So if you're in the middle of working something and you say, I don't fully understand coroutines, then you can come and look up coroutines. Or I don't fully understand delegates. You can look up delegates. And hopefully these won't auto-run on me, so go away. So essentially we have modules specifically for these, for lessons. So if there's a specific thing that you don't understand, look at the topic. But project-wise, I would do Rollerball, Space Shooter, Survival Shooter, and then Project Stealth. So the live training also you can find on the Learn site. And so the root site is Learn. The tutorials are what we just looked at. Come back here, the scroll bar. And where you are right now is live training. And we are currently doing, it's not listed because it's finished. We're considered done now. Absolute coding for the absolute beginner. Coming up next week, I have UI, panes, panels, and windows. Then we got tips and tricks. Then we have property drawers and custom inspectors. And then we should also start seeing Matt Shell doing some classes as well. He's been doing some persistent materials for us, getting ready for 5. Can we create anamorphic lens flares? Yes, you can. Yes, you can. Where would I do that? It's the easiest way. Documentation, manual, flares. Should give me something. Bloom lens flares. So the lens flare class is just the basic one, and it depends upon the shape of the art that you make, whether they're going to be anamorphic or not. And this is Bloom lens flares is an effect, and some of the effects may be pro only. So I would take a look at the first link before looking at the second link. And I think the type of flares you're talking about would be some mixture between the two. But definitely take a look at the image effects. And yeah, this particular one is Pro only. I don't know anything about 5 yet, like I said, because 5 is still in the works. Anyway, I'm going to go ahead and wrap it up. Thanks for coming. Please leave your suggestions on the forum. Free online training. So go ahead and leave your questions, comments, criticisms there. That's the best place to look for us. You can tweet us. So you can follow us or tweet us at Unity3D, at Mike Geig, at Will Goldstone, and myself at The Ant Ranch. And we'll be updating this card as we bring on Matt Shell. So I guess that's it. I think that's hopefully you learned something. And I'll wrap it up and say thanks again.